Assalamu alaikum. It's Vivian Shwaikani. I'll be explaining Chapter 11, Carboxylic Acids and Their Derivatives, Part 3. It is the last part in this lesson. In this lesson, we have to define the carboxylic acid derivatives, and we have to recognize them, and we have to study their chemical properties related to this lesson. First of all, let's start with the definition of the carboxylic acid derivatives. The derivatives of carboxylic acid are the compounds in which the hydroxyl group OH of the carboxylic acid is replaced by an atom or a group of atoms such as chlorine, Cl, OR prime, COOR. In this lesson, in this year, we have to recognize 4 derivatives of carboxylic acids, which are acyl chlorides, acid anhydrides, esters that we studied in the previous chapter, and amide, which is not required. So we have just to pay attention in this lesson to acyl chlorides and acid anhydrides as carboxylic acid derivatives. Let's start with acyl chlorides. What are acyl chlorides? They are the derivatives of carboxylic acid that are formed by replacing the hydroxyl group OH of the carboxylic acid by a chlorine atom Cl. So the general formula of acyl chloride is the following. Here is the C double bond O of the carboxylic acid, and here is the carbon chain. Instead of OH or at its place, we have chlorine. So this is the general formula of acyl chlorides. And if we have acyl chlorides having linear, it means non-cyclic, and saturated carbon chain, their general formula in terms of N will be CnH2n-1O and Cl. To be noted that acyl chlorides are more reactive than carboxylic acids, and this property is to be seen after a while. Now, let's move to the nomenclature of acyl chlorides according to IUPAC. Acyl chlorides are named upon replacing the suffix "ic" and the word acid of the carboxylic acids by acyl chloride. So the general name will be alkanoyl chloride. Let's consider an example in order to understand how to follow naming. For example, here is the molecular formula of the carboxylic acid having 1 carbon atom, so it is methanoic acid. Here is the acyl chloride deriving from this. As you can see here, this is the condensed structural formula. We have just 1 carbon atom attached here to H, here to the O with a double covalent bond, and here is Cl. So it's an acyl chloride with 1 carbon atom, so its name will be methanoyl chloride. Another example, here is butanoic acid, and here the acyl chloride deriving from it. As you can see, we have 4 carbon atoms in the chain, so the name will be butanoyl chloride. And I'd like to give you the following acyl chloride, which is C double covalent bond here, O and Cl, attached to the benzene ring or the phenyl as a branch, so it is benzoyl chloride because here is benzene ring. How to prepare acyl chlorides? Actually, acyl chlorides are prepared by 2 methods. The first one is to use PCl5, which is called phosphorus pentachloride, and the second by using thionyl chloride. Let's start with the first one. Actually, it's a reaction that involves the substitution of the hydroxyl group of the carboxylic acid by chlorine atom. So, here is the general formula. Here is the carboxylic acid, RCOOH. This is what we call phosphorus pentachloride. Penta because we have 5 chlorine. The prefix here, penta, means 5. It is PCl5. Once they are together, look what do I have to obtain here. The OH of the carboxylic acid is replaced by chlorine, and 2 other products are obtained, which are POCl3 and HCl. This reaction or equation is to be memorized by heart. It fits all types of carboxylic acid, and let's consider an example. Here is the phosphorus pentachloride, and here are the products obtained. Now let's consider this carboxylic acid. As you can see, here is the OH that has to be simply replaced by Cl. So as we can see, the same carbon chain is got here. Just we have a substitution of OH by ACl, and this is to be memorized by heart because you didn't see it previously. It's new. This is the first time you are taking this equation. The second method to prepare acyl chloride, it is similar, but now we are using another substance called thionyl or thionyl chloride, SOCl2. Here is the general equation. Here is the carboxylic acid. Here is thionyl chloride. As you can see, the OH of carboxylic acid is replaced by Cl, and two other products, which are SO2 and HCl, are got. Now, also let's consider the example. Here is SOCl2, and here are the products that are obtained with any carboxylic acid used. Here is an example. OH in this carboxylic acid, as you can see here, is replaced by a chlorine atom. Now let's move to another family of acid derivatives. They are called acid anhydrides. What are acid anhydrides? Acid anhydride is an acid derivative where the hydroxyl group of the carboxylic acid OH is replaced by what do we call the alkanoate group, which is RCOO. So the general formula is the following. It is in terms of N, when the carbon chain is non-cyclic and saturated, it is CnH2n minus 2O3. Pay attention, the single compound in this year studied that will has 3 oxygen atoms are acid anhydrides. But I want from you to memorize well this form, because look, we have here R, C double bond O and O, and we have another time C double bond O and R, as if we have a molecule made up of 2 parts. Here it was a carboxylic acid and here it was a carboxylic acid, so we have that symmetrical shape in its middle. C double bond OO and C double bond O. This is the general formula of acid anhydrides. Now how? Here just one remark, R and R prime here, it means can be the same or can be different. How to name acid anhydrides according to IUPAC? Here it's simple. The word acid in carboxylic acids is changed into anhydride simply. Now we have to consider first of all something called non-mixed acid anhydride. What does this word mean? It means that R and R prime in the molecule of acid anhydride are the same. Look at that example. If I have, for example, ethanoic acid, from which derive the acid anhydride, it would be called simply ethanoic anhydride. So as you can see, the word acid is changed by anhydride. Look at this example, which is the ethanoic anhydride. As you can see, here is the molecule. I have this part of it containing 1 carbon and the second carbon. So 2 carbon atoms, it means ethane. And here, C and C, it means ethane. So as you can see, R and R prime are the same. It would be called ethanoic anhydride. Look at that example. Here I have 3 carbon atoms, so it's a propane, and here it's a derivative actually of propane, and here 3 carbon atoms, so it is also a non-mixed acid anhydride. It would be called propanoic anhydride. So I repeat, this is simple for the non-mixed acid anhydride. Now how to name mixed acid anhydrides? As we said, anhydrides that are formed of 2 different carboxylic acids are called mixed acid anhydride, and they are named individually according to the alphabetical order. Let's consider an example. Look here. Here is the functional group of the acid anhydride. As you can see, C double covalent bond O, O in the middle, and C double covalent bond. So I have this part of the molecule and this part. This part consists of 2 carbon atoms, it means ethane, and this part of 1, 2, 3, it means propane. Which comes before in alphabetical order, E or P? It is E, so what will be the name? Simply ethanoic propanoic anhydride. Okay, here is the explanation of the alphabetical order. How to prepare a non-mixed acid anhydride? To prepare a non-mixed acid anhydride, we use what do we call the intermolecular dehydration of 2 molecules of carboxylic acid. Dehydration means taking out a water molecule. This reaction is carried out at high temperature, and in the presence of phosphorus pentoxide. Phosphorus pentoxide is a dehydrating agent, allowing the elimination of water molecule, as I said. Look, so as I said here, we are preparing non-mixed acid anhydride, so the two molecules of carboxylic acid has to be identical. So simply, we have to use two molecules of an identical carboxylic acid in the presence of P2O5, which is, as we said, a dehydrating agent. Simply R, C double covalent bond O, O that is in the middle, C double covalent bond O, and R is got plus H2O that is eliminated from two molecules of carboxylic acid. Okay? Here is an example. Here, for example, two molecules of ethanoic acid. So automatically we will get ethanoic anhydride plus definitely a water molecule that is eliminated from these two molecules. Now, how to prepare a mixed acid anhydride? Here we can think in the same way. It means we can use the two molecules of carboxylic acids that are different and we will get acid anhydride. This is true. But here we have a problem that in this case, three types of acid anhydrides are obtained. Look how. For example, I have this this carboxylic acid and this carboxylic acids that are different because R and R prime are different. So first possibility that this molecule and this molecule combine together with the elimination of water molecule to obtain this mixed acid anhydride. But don't forget that here we are using moles. It means we have a huge number of molecules of these two species in the reaction medium. So two molecules of these, for example, can react together producing the following acid anhydride. It means the dehydration will occur between these two molecules of acid anhydride. Okay, and the water molecule is obtained. And at the same time, because we have plenty of molecules of this type, also each two molecules of these can react in order to produce this type of acid anhydride and water molecule is eliminated. So upon mixing two different molecules of carboxylic acid, definitely with a given amount, because in chemistry we are using moles, three types of acid anhydrides will be used. Practically, this is not good because imagine that I'm in a factory, I'm paying money in order to produce this compound, but at the same time, I'm wasting my money because another products that I don't need are obtained. So in industry, we have to find other practical method in order to prepare a mixed acid anhydride. This method is the following. Here is just an example so you can see it quickly. And here, as I said, phosphorus pentoxide is a powerful dehydrating agent that allow the elimination of water molecule. Now, what is the practical method used to prepare a mixed acid anhydride? It is the following. A mixed acid anhydride can be obtained without any other non-mixed anhydride. It means just alone by the reaction between an acyl chloride and sodium carboxylate, which is a salt having RCOO- and Na+. This is called sodium carboxylate. So look at that example. If we want to obtain ethanoic propanoic anhydride, what do we have to use? We will use this acyl chloride with how many carbon atoms? 2. It means ethanol chloride, and here 3 carbon atom. It would be sodium propanoate. Okay, the Cl from here and Na+ from here will be together to form NaCl, and this oxygen here will attach to this carbon here, producing this mixed acid anhydride. Or we can use this, here is Cl and NaCl, as I said. Or we can use the following. The acyl chloride can be with 3 carbon atoms. It means it would be propanoyl chloride, and the sodium carboxylate will be with 2 carbon atoms. It means sodium ethanoate, and the same acid anhydride is got here plus NaCl. So I repeat, if I have to prepare a mixed acid anhydride, I will look to the number of carbon chain here and number of carbon atoms here, and I will use the ethanoic chloride as this one and sodium carboxylate as this one, or the other way around, the same acid anhydride will be got. So here also it's something to be memorized by heart, how to prepare a mixed acid anhydride. Now, we know well the esterification reaction is studied in details in part 2 of this lesson. In this lesson, we defined esterification as the reaction between alcohol and a derivative acid or one of its derivative. And I told you that you will not understand why did I write acid derivative, but now you have to understand. Let's see esterification using acid anhydride. The reaction of acid anhydrides and alcohols, so as you can see, the carboxylic acid in esterification is replaced by acid anhydride, produces ester and carboxylic acid. Look how this is the general equation. This is the acid anhydride, this is the alcohol. So the ester got will have the R prime of the alcohol and one R here of the acid anhydride, and this molecule is split in two parts where one of them will give me again a carboxylic acid. So this is esterification simply because ester is obtained. Here there is an importance or a property or an advantage of using acid anhydrides at the place of acid chloride. You know that esterification reaction using acid, carboxylic acid and alcohol is reversible. It means it is not complete and it is a very slow reaction and it is athermic one. Here using acid anhydride, esterification is complete. It means the yield is greater and it's faster than esterification using carboxylic acid, and it's exothermic. And these are very important properties for this reaction. Also, there is a remark to pay attention to. You have to be asked in exercises about that. This type of reaction, like esterification, has to be performed in a perfectly dry medium. Why? It means we don't have to have either one droplet of water to avoid the hydrolysis of acid anhydride, because this acid anhydride can split into two carboxylic acid, and this is, we have to see it after a while. Now, esterification can be used also using acyl chloride as the carboxylic acid derivative. The reaction of acyl chloride and alcohols produces ester and hydrogen chloride according to the general equation. Here is the acyl chloride, here is the alcohol. So here is the ester obtained. This is why it is called esterification. And Cl and H from here combine together to give HCl. This is an example, okay? Now, here also you have to pay attention that this reaction is complete, faster than the esterification using carboxylic acid and exothermic. Again, this reaction has to be done, here in a perfectly dry medium to avoid also the hydrolysis of acyl chloride. And acyl chloride are more reactive than carboxylic acid and then acid anhydride, and this is why this reaction is also can be done, but acid anhydride is more favorable because in industry, in laboratory, it is easier to deal with acid anhydride because acyl chloride are very, very reactive. Okay? Now, what about hydrolysis? You know that when I say the word hydrolysis, it means I'm talking about a reaction of decomposition using water. So hydrolysis of acid anhydride, it is simply the reaction between water, H2O, and acid anhydride. Here is the acid anhydride, here is the water molecule. Simply this acid molecule, it means, will be cut into two, giving again the two carboxylic acids, making this acid anhydride. So this is hydrolysis. Actually, it is the opposite of the dehydrating of acid chloride to obtain acid anhydride. And this is why we said that we have to avoid the presence of water, because in a very simple way, acid anhydride can be hydrolyzed. Here is an example. Here you have ethanoic anhydride, so plus H2O, it would give me two ethanoic acid molecules. Hydrolysis of acyl chloride, again, I want to go directly to the example. Here is the acyl chloride, that is ethanoyl chloride plus water. You have to see that again I will obtain the carboxylic acid with 2 carbon atoms, it means ethanoic and HCl. Here also I will remind you that any reaction having acyl chloride, we have to perform it in a dry medium to avoid the hydrolysis of acyl chloride. Now, what are the characteristics of hydrolysis reaction? It's complete, fast, and exothermic, but this one is not to be memorized. Let's do this application without do any pause. I want you to write the esterification reaction between ethanoyl chloride and methanol. So it's an alcohol and derivative of carboxylic acid. Automatically, it's esterification. And specify the importance of using ethanoyl chloride instead of ethanoic acid. It's a typical question. So here is the reaction and here is the importance. Using ethanoyl chloride instead of ethanoic acid makes the reaction complete because the yield is increased up to 100% and makes the reaction fast. While you know that in a typical esterification, the highest yield obtained with a primary alcohol is about 67%. So here is much greater and it's very slow esterification using carboxylic acid. Here is fast. I will ask you to memorize this sentence because you have to use it in exercises when you have to justify the importance of using acid derivatives instead of acid in the esterification reaction. Here are some important remarks you might face in exercises. For example, if you are asked, why should we use dry containers while using acyl chlorides or acid anhydrides? You know it now because we repeated. Simply to avoid the hydrolysis of these compounds into carboxylic acids, since these 2 compounds are very reactive with water. Another question, what is the order of reactivity of the acyl chlorides and acid anhydrides in comparison to carboxylic acid? Here is the rank. Acyl chlorides, as we said, are the most reactive. Then comes after them acid anhydrides, and carboxylic acids are the least reactive compared to these. What is the characteristics of esterification using acid anhydrides? So you have to say that it is complete, fast, and exothermic. Same question can be asked using acyl chloride. The same answer will be. So here there is a remark to be said. In reality, the esterification using acid anhydrides is slow. It is not fast, but it is faster than using carboxylic acid itself. Now, in the Lebanese curriculum, they mentioned this information in the book as fast, and in the official exam, they will not consider it as faster. They say simply fast. So you have to be limited to what is mentioned in your book, and you have to say that it is fast and not slow. Okay? And here is the last part of carboxylic acid. Thanks for watching and see you in the next video.